Hi everyone, welcome to Power Electronics video lecture. Myself M. Krishna, working as Assistant Professor in EEE Department, St. Peter's Engineering College, Hyderabad. Here in this video, I am going to explain DC Morgan chopper. So this is the circuit diagram of DC Morgan chopper. The circuit diagram consists of one thyristor, two diodes, and a capacitor. There is one load. Very important element which we can find in the circuit configuration is saturable reactor. Here the saturable reactor plays a vital role in this operation. See, here the saturable core reactor replaces the inductor for the purpose of LC oscillation. The load is assumed to be constant and it consists of a DC motor running at a constant speed. In this circuit, thyristor is used as a switching device, while the capacitor C and diode D1 and saturable reactor SR all together make a commutation circuit which is needed to turn off the thyristor. So we'll see the operation of DC Morgan chopper. So these are some modes of operation which we can see in the following slides. In this video, look at the diagram. The path of current after switching on a thyristor. Before switching on a thyristor, there is one operation at what we call till less than T1 period. We'll see the first this one when the switch is on. As we have one assumption in this case, that is the capacitor which we connected in the circuit is already having some voltage across it, means it is already charged, like positive polarity, positive plate means upper plate is positive polarity and negative plate is having negative polarity. And the DC motor and the battery minus E path as shown in the figure, and the resultant the current with the positive saturation of the saturation reactor. The actual sequence of the operation starts with the thyristor being triggered at t equal to 0. During this operation, the load current will not flow through the capacitor. Here no current flows through the capacitor, all current flows through the thyristor to the load and back to the source. Hence load current flows through the battery, thyristor, lower half of the saturable reactor and to the external inductance. And this diagram indicating the when the switch is not closed, before the switch is on, what happened is whenever the supply is connected like this, the current path is in this manner because the diode seems to be reverse biased here. The thyristor is not at all triggered. That's why the voltage which we applying to the circuit will force one current in the circuit which is flowing through like this through a capacitor SR and external inductance to the motor and back to the source. In this condition, as we said, the capacitor is charging, and hence the capacitor voltage reflects across the saturable reactor, and due to which the core flux saturation flows from positive to negative. Once the negative saturation of the core flux reached, the operation is taking the negative way. In this equivalent circuit, it is the equivalent circuit for the discharging path of the capacitor through the thyristor. Look at this. This is the upper plate of the capacitor having the positive polarity, lower plate is having the negative polarity. The current is coming out from the positive terminal and entering into the thyristor. And look at this, the polarities across the capacitor, polarities across the thyristor, polarities across the diode, and diode becoming reverse biased, thyristor becoming closed, means on, hence the discharging path takes place through thyristor like this, and there is no connection to the load in this duration. And in the diagrams you can able to see two currents. One current is a separate current which is flowing through the load, the other current is available in this circuit. Two sub circuits are available, and one current is a discharging current, the other current is freewheeling current. Freewheeling current which is related to the load, and this is the current which is flowing through the diode and capacitor through half of the portion of the saturable reactor. Here a very important thing is that the saturable reactor having a low impedance value when it is not saturated and allows the more current to flow. When it is saturated, it offers the high impedance value which does not allow the current to flow through it. And we can able to see the Morgan-Chopra output waveforms. Here Ig1 is triggered at some intervals like this, and this is the voltage across the thyristor. If the thyristor is on, there is no voltage across the thyristor. If it is off, there is a voltage across the thyristor according to open circuit concept and short circuit concept. Here also the current allowed to flow when it is short circuited, conducting like this, and there is a capacitor. The current flowing through the capacitor takes the wave like this for the different timing values. And as I said initially, the capacitor is charged and it's going to be discharged according to the operation like this, having a positive value, negative value like that. And this is the current voltage across the diode, and it is maintaining the same value as same as the capacitor, but the magnitude values are going to be changing based on the timing values. And the current flowing through the diode is always maintaining the constant value, we can able to see in the waveforms. This is the freewheeling diode current. It's conducting only when the supply is not available, when the capacitor unable to supply the power to the load, or saturable reactor unable to supply the power to the load. In that condition, the inductor, external inductor which is there in the load circuit will provide the source to the load, and it is driving the current through the load through the freewheeling diode. Here the freewheeling diode getting short circuited, hence the voltage across short circuit is always 0. The same voltage is available across the load side.